two things we are talking about today. The first one is function notation. Some of it you've seen before, most of it you have. Some of it you have not seen. And then the second half of notes is going to be graph translations, which if you took, and symmetry. If you took math applications, that's where we took a graph when we moved it left, right, up, down, reflected it. So that you've seen before, and then the symmetry you have as well. We're going to do function operations, take a break, and then we'll look more at the graph. Okay, so jumping into our first example, we are given two functions. We're given this f of x, and we're given this g of x. And we have to find a whole bunch of different items. Example A is asking us for f plus g of 3. So we have two different options. We can find f plus g first, and then plug in 3, or we can start by plugging in 3. What I'm going to do is I'm going to start by finding f plus g of x. All that means is add f and g together. All we're doing is adding f and g together. So f is x squared plus 2, g is 3x minus 1. Now, technically that does simplify. So this becomes x squared, add 3x, add 1. That's not what we're asked for though. We're not asked for f plus g of x, we're asked for f plus g of 3. Which means what we now need to do is plug 3 in. So we have our f plus g of 3, which will be 3 squared, add 3 times 3, add 1, which I believe is 19. So all you're doing is following the sign. Okay, B, the little dot means multiply. So we're taking f, multiplying it by g. So our f multiplied by g of x is going to be x squared, add 2, multiplied by 3x minus 1. Now, I do not want us to do extra work. There is no reason to multiply this out. There's no reason to FOIL it out because what we're going to be doing eventually is plugging 4 in. So let's just plug 4 in right now. Don't bother to FOIL it and then plug in 4. Plug in 4 right away. So our f times g of x is going to be 4 squared, add 2, and then 3 times 4 minus 1. So this is 4 squared, 16, add 2 is going to be 18. 3 times 4 is 12. 12 minus 1 is 11. So I guess I lied to us. I need a calculator at least for this. So our 18 multiplied by 11 will give us 198. Okay, C is different. This notation in C really matters. If the circle is filled in, it's multiplication. If the circle is not filled in, that's not multiplication. It's something called a composition. So if you can write that down, this is a composition. I don't like that notation, so I always rewrite it. It means this, f of g of negative 1. That's what we're doing. So we're plugging negative 1 into g, figuring out what that is, and plugging it into f. So we will start with g of negative 1. So that's 3 multiplied by negative 1 minus 1, which is negative 4. So this g of negative 1 is negative 4. So what we're doing then is plugging that into f. So we are now doing f of negative 4. So that's negative 4 squared, add 2. Be careful with your parentheses here. The negative goes in parentheses because we're squaring all of negative 4. So this will be 16, add 2, which will give us 18. Those are the first 3. Questions on those before we switch gears a tiny bit? No? We're good? Okay. In D and E, there's a big difference compared to what we just did. In D and E, when we look at our notation, there's an X here instead of a number. So in A, B, and C, when you see a number here, what that tells you is that your answer will be a number. In D and E, when you see an X, your answer will be in terms of X. So D, we're subtracting. We're taking F, we're subtracting G. Please make sure you use parentheses. So we're going to have x squared plus 2, and we are subtracting 3x minus 1. So this is x squared plus 2 minus 3x plus 1, which simplifies to x squared subtract 3x add 3. So again, because there's an x here, your answer needs to be in terms of x. You could plug something in now if you wanted to, but you don't need to. Oftentimes, you're going to be followed up by being asked for the domain. Without even picking up a calculator, you should be able to tell me what the shape of this is going to be. Parabola. How do you know?
Because it's squared.
X squared. X squared. So we know it's going to be a parabola. What else do we know? It's going to open up because of the 1x squared. What is the domain of any parabola that opens up? All real numbers. Yeah, our domain is going to be negative infinity to positive infinity. The graph forever goes left, forever goes right. We can't put a wall on either side. Okay, in E, this symbol is division. It's asking us to take F and divide it by G. So that's going to be x squared plus 2 over 3x subtract 1. So that's F divided by G. That's it. Don't do anything else. Don't go any further. That's your full answer. This domain is a little bit trickier. I would suggest you don't use a calculator for this one. I would suggest we just think about a fraction. When we talked about a fraction, what have we said is our biggest concern, our biggest area of concern? Charlotte, you're on fire today. What is it?
You can't divide by 0.
Can't divide by 0. So for our domain, our denominator cannot be 0. If we solve for x then, x cannot be 1/3. So 2 ways to write the domain. X can be any number but 1/3. That's probably the easiest way to write the domain. If you prefer to write it in interval notation, we can do that as well. Interval notation would be negative infinity to 1/3, and then again 1/3 to infinity. Either of those would be acceptable. I would probably use the first notation because I think it's easier to write than interval notation for this one, but either one will work. Okay. Questions? No questions? Charlotte?
Do we have to write the U?
Yes. If you're going to do interval notation, yes, you need the U. Okay. You also need to be able to find information like this off of a graph. So that's what we're going to do next, is find quantities such as these off of a graph. So let's look at example 2. We are given the graphs of f and g. Okay, first thing I'm going to do, please label these. So the red one is f of x, and the blue one is g of x. You might not need that. I need it, though. Okay, we are finding these 4 quantities based off of the graph. I'm going to start with A. First thing I'm going to do is rewrite this. So this is the same as f of g of 0. So again, this is a composition. It's not multiplication. It means plug 0 into g. Whatever you get, plug it into f. G of 0 is the y value when x is 0. So we're going to go on our graph for g. When x is 0, the y value is negative 2. So g of 0 is negative 2. We're finding then f of negative 2. So g of 0 is negative 2. When I go to x, it has a y value of negative 2. So now I'm saying x is negative 2. What's y? using function f. So x is -2, y then is 4. So our final answer here would be 4. This, I'm fairly confident you haven't seen before. You've seen the compositions, but probably not off of a graph. Let's do B. If we rewrite this, this is g of f of 0. G of f of 0. So we're starting with f of 0. X is 0, what's y? So going to our graph, we're on f. When x is 0, y is also 0. So f of 0 is 0. That's then what we're plugging into g. So again, this notation, look at function g. If x is 0, what's y? If x is 0, y is -2. So this gives us -2. One thing I want you to notice, if we flip f and g, the answers are different. So these two have different meanings. Just make sure you pay attention to that. Questions for me before you're going to try C and D? Does anybody have the confidence to talk me through what you did on C? Or even to start me out? Audrey, thank you.
Well, I'm not super confident, so this might not be right.
Okay.
But first I changed the writing, I guess, to f of g of 1.
Okay.
And then I looked at what the x, like I went to the x being 1, and then I went down 1 to f of -1.
G of -1?
Or yeah, g of -1.
Okay, so I'm going to write and then I'm going to have you keep talking.
Okay.
So what she said is she went over to x is 1, and then she figured out what the y value is there, and the y value was -1. Do I follow what you did so far?
Yeah.
Okay, then what'd you do?
And then I went to the x-axis again, and I went to -1, and then I went up to 4.
Beautiful. It's fantastic. Perfect explanation. So she found g of 1 first, which is -1. She went over to 1, found out that that gave her a y value of -1 on g. Then she plugged that into f. So what she said is she started back at the origin. This time she went to an x value of -1 and figured out that the y value there was +1, giving a final answer of +1. D? Come on. Nobody else in this class? Eddie, thank you.
So I looked at it as g of f of 2. And so f of 2 is kind of like f of x. So I followed the x-axis to 2 on f of 2.
Okay.
Then I went up to 4, so I got g of 4. And I did the same, so I went over to 4 on the x-axis and went up to g of 2.
Beautiful. Thank you so much. Okay, both of those answers are right, so I'm going to reword what Eddie just said. Eddie said, I found f of 2. So, whoa. Are you guys going to tell me I went the wrong direction on my graph? What did I do wrong? Audrey?
You went to -2.
Yeah, I went to -2, not +2. Oh, man. Okay. Let's try this again. Okay, so what Eddie said is went over to 2 and figured out that that gave him a y value of 4 on f. So that means that f of 2 is 4. Then what we got to do is go over to 4 on g. So go over to 4 on g, which gives a y value of 2. I feel like we need to do one more before we take a break. And this is going to be a fun one, I promise you. We are going to do g of f of g. I got to pick a value before we actually do this. That's what I want you to find. G of f of g of 2. So you're going to have to do 3 plug-ins. Right now, turn to the person next to you and talk through this together, please. Correct answer is -2. Correct answer is -2. Here's how. We start with g of 2. G of 2 is 0. Then we have f of 0. F of 0 is 0. And then g of 0 is -2. Remember that I told you we do this because you're going to see it again. So, I understand that that's something you haven't seen yet. It might be a little tricky. And if it is, please ask and we can go through some together. You can flip to the next page. Next thing we need to talk about is a translation. So like I said, those of you in math applications have seen translations before. It's when you take a graph, you move it left, right, up, down, maybe you reflect it or you flip it. Here's a lot of information. Here's what you need to know. If a number is outside of the parentheses, it's going to move us up or down. If a number is inside parentheses, it's going to move us left or right. If you remember, the left-right is always the opposite of what you think it's going to be. You know what? I'm going to do this differently. I think this is a lot of information that's not particularly that helpful. So, we're going to go to the bottom of this page. If you want to read through all of those, you are certainly welcome to. Before we do example 3, I'm just going to write down the rules that you need to know. So if you could write these down with me, I would really appreciate it. Okay, first of all, here is our general function. We could have something outside, we could have a few things inside, and we could have things outside. So, A, B, C, and D are all things that are changing our graph. So if we were at the most complicated translation, we would be doing 4 things. Here's what I need you to know. First idea. Anything inside parentheses affects X. So B and C that are inside parentheses are going to affect X. Anything outside the parentheses affects Y. So this affects X. The A and D that are outside the parentheses affect Y. Okay. So if we are adding something, it's moving us. Adding something is moving us. So this C is going to move us, and the D is going to move us. C is going to move X. C is going to move X, so it's going to move us left or right. D is also going to move us. It's outside parentheses, though, so it affects Y. Y is up or down. Okay. Next thing that you need to know. There are 2 things that happen. So if we look at what's affecting X, we have a number being multiplied and we have a number being added. The multiplying is a reflection. It's going to reflect us. The adding is going to move us. What you need to know is that reflections happen before movement. And that is always the case. So our reflections are A and B because they're being multiplied. So we would always do A and B before we move it all. And lastly, changes to X happen before Y. Okay. Because most of us have seen this before, I think it's going to be easiest to just do some examples, and hopefully that will help us. Okay, if we look at example number 3, given y equals f of x, describe how you would obtain the graph of the following. So here should be your thought process. In A, f of x plus 4. First thing you got to ask yourself is, does that plus 4 affect x or y? So, x or y? X, right? Anything inside parentheses affects x. X is going to move us left or right. So what we have to figure out is, are we going to move left or right? Yeah, this is the one that's opposite of what you would think it would be. I would think plus 4 moves us right. X is the only one that's a little bit funky. So what this is going to do is it's going to move us left 4. Let's skip to C and then we'll go back to B. For C, does this negative affect x or y? Y. Outside parentheses affects y. I don't use fancy vocabulary. You don't even need to use the word reflect. All I need you to know is that we are going to multiply all the y's by a negative. That's all you need to know. You're going to multiply all the y's by a negative. So if your graph is up here, it's going to flip down. When we get to something like B, this one's a little bit more complicated because we have two things that are going on. This negative affect x or y? X. The negative 10, x or y? Y. So inside parentheses x, outside parentheses y. The multiplication or the reflection always comes first. So we're going to do this one, then we're going to do this one. So the first one is going to multiply all x's by a negative. The second one, which affects y, is going to move us up or down. What is it going to do? Move us up or down? For y? Down. Yeah, it's what you think it would be. We're going to take the entire graph and we're going to move it down 10 points. Charlotte?
If you were to write a reflection, would it be a reflection over the x or over the y-axis because it's
Okay. I'm going to help us out with D and then I want you to finish it. 3 things happening. The negative, the 5, and the negative 1. Keeping in mind that reflections always happen first and that changes to x happen before y. What is the first thing that we're going to deal with? The negative, the 5, or the negative 1? The negative. The reflection will happen first. And then what? The negative 5 or the negative 1? What? Negative 5, thank you. And then the negative 1. Take 30 seconds, please, and write out what those 3 will do. That negative is going to multiply all of the y's by a negative 1 because it's outside. Inside parentheses, opposite of what you would think it would be, it's going to move us right 5 and then down 1. How'd we do? Okay? Okay, you're going to see this idea in the homework. It's going to be worded a little bit differently, though, but it's the same idea. We have one more of this to do, then we're going to talk about symmetry. Fingers crossed, I think we'll be done in the next 9 minutes. Questions before we do the last example of this kind?
If we do this on like a test, can we put
You can put reflect as long as it's the right reflection. So for this one, if we're changing y, reflecting this way, it's going to reflect over the x-axis. Okay, next page. This is the last one. You're going to do this one. Here's what you're doing. The graph that you see is f of x. What I want you to do is graph this one. So figure out what does the plus 1 do, what does the plus 2 do, draw yourself a new graph. Elliot, what does the plus 1 do?
Moves it one to the left.
Moves it 1 to the left. And what does the plus 2 do?
Up to
And what are we going to do first?
the X.
Okay. This is what I got. Elliot, did you get the same?
Yeah.
Great. So, left one, up 2. Okay. Questions for me? Okay. Last thing we have to talk about is symmetry. Those of you who took math applications, we tested for symmetry using equations. That's not what we're going to be doing this semester. This semester, all we're doing is looking at a graph. So again, I'm not going to bother to read through all of this. What I'm going to do is show you examples how you can tell if something is symmetric based on a graph. Okay, if we have a graph that is symmetric with respect to the y-axis, when you draw a line down the y-axis, the graph should have an exact match on the other side. So this first example, draw a line down the y-axis. This has a match on the other side, a reflection. They should be two mirror images of each other. If something is symmetric with respect to the x-axis, when you draw a line down the x-axis, again, the graph should have a match. If we were to fold it on the x-axis, the two halves are going to fall on top of each other. One is a reflection of the other one. If you want to know what that looks like symbolically, you can read the text. Okay, last one. This one you're going to have to write down. Origin. If something is symmetric with respect to the origin, it is going to reflect over both axes. And I'm going to draw an example because there's not one here. For example, if this was the start of my graph, if I reflected over the x-axis and the y-axis, order doesn't matter, so I reflect over x, and then I take that and I reflect it over the y, then this whole graph is symmetric with respect to the origin. Because if I take one half and reflect it both ways, I'm going to get the other half. So that's, the origin is the tricky one. Again, though, it's the entire green graph that is symmetric with respect to the origin. All you're going to have to do is look at a graph and tell me what type of symmetry it has. It is certainly possible, though, to have no symmetry. So just know that. Questions before we look at our last example? Okay. Last example. All we are determining, does the graph have symmetry with respect to the x or the y-axis? We are going to do B and D, and you're going to do A and C. Okay, B, any ideas? Symmetric with respect to x-axis. If we draw a line down the x-axis, one half of the graph will fold on the other half. So that's B. D. It doesn't have symmetry. So for D, you can just write none. You take 30 seconds and do A and C, please. Let's finish these notes then. Martina, A?
Is it the origin?
It is the origin. I agree. Origin. In my opinion, that's the one that's hardest to recognize. If we take this part of the graph and flip it and then flip it again, we get the other half of the graph. O and C? Okay, Alexia? Y-axis, thank you. y-axis. If we draw a line down the y-axis, our two halves will fall right on top of each other. And that's it.